Good morning to all. Now we are going to discuss the Fermi energy based on the Sommerfeld theory. In the last class, we discussed the formation of different energy level based on the Sommerfeld theory, and we find out the final expression for the energy of the electron in the n state. En is equal to n square h square divided by 8 ml square. So we've written it as En proportional to En square, and if we draw a graph, it is exponentially increases with respect to N and En. Now, and we find out the wave function as psi n of x is equal to root of 2 by L into sine n pi by L into x. This much of we discussed in the last class. Now we are going to discuss the Fermi energy. Fermi energy. Actually, Fermi energy is defined as the topmost filled energy level at absolute zero temperature. In last class, based upon free electron theory, we discussed as the electrons are free to move. Let's consider if there is n occupying state for an electron. It is a well, or the electron is trapped in a potential well, or just we consider it is a finite well or infinite well. We'll consider this is the first state, this is the second state, this is the state, or different principal quantum number n. So we can write it as it is n equal to 1, this is n equal to 2, and here n equal to 3. Let's consider if the electron is filled only up to the first level, then that is called the Fermi level. The topmost filled energy level at absolute zero temperature, at 0 Kelvin. That means without the presence of any external energy or temperature, the topmost filled energy level within a molecule or atom, that is considered as the Fermi level, and the energy is corresponding to Fermi energy EF. Now here EF, we can write it as EF is equal to, from this equation, n square h square by 8 ml square. So when n is equal to 1, this is h square divided by 8 ml square. So it is unit of within the unit of h square by 8 ml square. When n is equal to 1, it is 1 square. When n equal to 2, it is 4. When n equal to 3, it is 9. So we can write it as the energy if in the units like this. So energy is equal to is in the unit of, that is increasing and the height of potential increasing, and energy is in the unit of h square by 8 ml square. If n is equal to 1, it is 1 square into this value, this is 2 square into this value, this is 3 square into this value. And also, let's consider the wavelength of this, if consider the electron as a wave, I'll consider this much of length is equal to 2L, and this is the two boundary condition, and we can take it as lambda is equal to 2. When n equal to 2, this wave is like this, then we can define as lambda is equal to 2L by 2, or 2L by 2 means lambda equal to 2L by 2, that is equal to L. I'll consider here lambda is equal to 3, then his wave is like this. Then lambda is equal to 2L by 3 or 2 by 3 into L. So n is equal to 4. If n is equal to 4, then lambda is equal to, if there is one more level is there, then 2L divided by 4, that's equal to L by 2. So successively we can write from lower state to another higher state. depend upon the principal quantum number or quantum number n. The first state, let 2L, is the wavelength of the wave function of the electron. Then here it is 12 by 2, 12 by 3, 12 by 4, 12 by 5, etc. That we just be represented this in this side, and the principal quantum number is given here. And from lower level to upper level, the energy increased in unit of h square by n square. For first level, it is 1 into h square by 8 ml square. And for level 2, that's is equal to n square. That's equal to 4 into h square by 8 ml square. So the unit is this one. And with respect to n square, the en is increasing gradually to the positive axis. So the topmost field energy level at absolute zero is considered as a Fermi level, and corresponding energy is called Fermi energy. Let's consider if we have capital N number of electrons. Consider we have capital N number of electrons. Then we can write it as EF is equal to, the Fermi energy is equal to h gut square divided by 2m into n pi by L whole square. In this equation, h by 2 pi, that is written as h gut. Then the equation that we can be modified into the Fermi energy h gut square by 2m into n pi by L whole square, or we can written as h gut square by 2m into n is called Fermi level. Energy equivalent to Fermi level is called Fermi energy. So we can write it as NF is the Fermi level into pi by L whole square. Now we think that let's consider this is the first state. If n is equal to 1, if the principal quantum number is 1, according to Pauli's exclusion principle, one upward spin and one downward spin is possible there. Then if NF is the Fermi level, so in each level 2 into NF number of electron is possible. So 2 into NF, that is taken as total number of electron. That N is equal to total number of electron, that is equal to 2 into NF, or we can write it as NF is equal to capital N by. Now we can replace this small this NF by using this equation capital N by 2. Then our equation EF is equal to h gut square by 2m into n pi by 2l whole square. This is the expression for Fermi energy. And what are the parameters? Here it is 2L. So the Fermi energy depends on, or inversely depends on, the length of the potential well. And it is proportional to the square of the number of the electrons present in a particular level of energy level. So the Fermi energy, the topmost filled energy at absolute zero, is dependent upon the length of the potential well or particle in a box, length of the box, and it also proportional to the number of electrons present at that state. So when we considering an atom, we have to find out a theoretical value for it. Let's be for an atom, the approximate value of N by L is equal to 0.5 electrons per atom. Per angstrom, sorry. If actually this N by L value, this N by L value, this N by L value approximately 0.5 electron per billion. So we can write it as, maybe we can take a 1 angstrom is equal to 10 raised to minus 10. Then we can write it in centimeter, then 5 into 10 raised to 7 electrons per centimeter. Then the Fermi energy that we can be calculated because all other are constant. H is equal to h by 2 pi. 1 by 2m is the mass of the electron. Pi is the 3.14. Then E of Fermi energy is equal to 3.7 into 10 raised to minus 12 erg, or we can write in an SI unit on an electron watt. Approximately Fermi energy is equal to 2.4 electron when n by L is equal to 0.5 electrons per. So this is the expression for the Fermi energy equivalent to an atom at absolute zero temperature. So here we can accommodate 5 into 10 raised to 7 times of electrons on 1 centimeter with the energy of the electron with the topmost filled level is equal to 2.4 electron. That is some physical concept of this equation. That means we can accommodate 5 into 10 raised to 7 times of electron per centimeter with Fermi energy or the topmost level energy 2.4 electron volt. This is the case of Fermi level and the expression for the Fermi energy. Let's have Fermi energy EF. EF is equal to h hat square by 2m into n pi by 2l whole square. This is the expression for the Fermi energy. So we want to by heart this equation to doing the problems. EF is equal to h hat square by 2m into n pi by 2l. Actually, this is equation is similar as this one. No problem. Here just replace small n is equal to n by 2. N by pi by 2l whole square. This is the expression that we want to study. So we calculated the expression for the Fermi energy. Now we can calculate the total energy of this arrangement of this electron. If there are capital N number of electrons, find out the total energy due to the presence of these all electrons. So next we are going to study the total energy of this electron. So let E0 is the total energy is represented by the letter E0. And if there are capital number of n number of electron is there, we can know that by Pauli's exclusion principle, half number of orbitals or states is required to n by 2 number of states, electronic states is required to accommodate capital N number of electrons. So we can calculate if En is the total amount of the energy. So total energy is represented as E0. E0 is equal to 2 into summation over n equal to 1 to n. So we want to calculate for each level E1, E2, etc. up to En by 2. That much of level is present into 2 times because total number of electron is in each level 2 electrons present or 1 upspin or 1 downspin based upon the Pauli's exclusion principle. Now it's very simple. We can write the equation of En here, substitute here, and we can find out the expression. So that is equal to 2 into summation over n equal to 1 to n by 2 h square or h hat square by 2m into n square pi square by L square. Here the varying quantity is n, all other as constant, 2h hat square by 2m into pi by L all square into summation over n equal to 1 to n by 2 n square. Now we want to calculate the expression of this value and substitute in this equation. And approximately by the expression of binomial expansion, summation over n equal to 1 to any value if it is considered just B, it is S. Yeah, summation over n square is equal to 1 by 3 times of S square. So here our S is up to n by 2. So our value is approximately, sorry, 1 by 3 into S cube, approximately 1 by 3 times of S cube. And here our value is n by 2, that's equal to 1 by 3 into n by 2 all. So we can substitute this value for here. And the expression is equal to 2h square by 2m into pi by L all square into 1 by 3 into n by L all cube. Now we can rearrange this value, that is equal to, we can cancel this 2 and here n pi by 2L, n pi by h is equal to 10 n pi by 2L. Here is n by 2. So that is equal to 1 by 3 into h square by 2m into n pi by 12 whole square. Then 1 n is remaining here into capital. So this is the, by rearranging we obtain this equation like this. I will send the note photograph of this page also. You can just rearrange the equation we obtain like this, and that is equal to 1 by 3 times this h square by 2m into n pi by 12 whole square. That is we calculated in previous equation, that is our EF. That is equal to 1 by 3 into EF into capital N, or we can write it as 1 by 3 n into EF. That is E0. So if EF is the Fermi energy, the total energy is equal to 1 by 3 into total number of the electrons into the energy of the Fermi level. So if there are three different states and let EF is the energy of the topmost field, then the total energy of all these is equal to 1 by 3. Here n number of, if 6 electron, we can write as 6 into this EF, or capital N into energy of this Fermi level. That is equal to the expression of the total energy E0 of the Fermi level, or the total energy of this particle in a box, or due to the Sommerfeld theorem. One more topic is there we want to discuss, that is the density of states. So the density of states is explained that it is represented by the letter D of density of, that we also now studied in distribution laws. D of E is equal to dN by D. Here we know capital E, so we can calculate D by dN. That is possible here. Here dN is the number of quantum state in the energy level E to E plus D or delta E. dN is the number of electronic quantum states with the value of energy E2 E plus delta E or E plus DE. Since each level has 2 electrons, as we know, we can write it as D of E is equal to 2 into dN by D. Now, so there is no need to write this. This level is again dN by D into 2. That is the total number of the electron present due to if one level contain 2 electrons, 2 times. So D of E is equal to 2 into dN by D. Here it is simple to solve this equation by E. So we can calculate D by dN. by calculating this value, we can just take the reciprocal, then we obtain dn by d. So our expression for En is equal to n square h square divided by 8 ml square. From this equation, we studied this equation from Sommerfeld theory, or En proportional to n square. So we can take the derivative of this equation d by dn with respect to n. We can take the derivative of n square is equal to n. So h square divided by 8 ml square into 2n. Or rearrange this equation, we can cancel this 2 and 8, that is equal to 4 ml square. That is equal to d by dn equal to h square n divided by 4 ml square. Now take the reciprocal, dn by d is equal to dn by d equal to 4 ml square divided by h square. So that is equal. So here we can substitute this equation here. So density of state is equal to 2 into 4 ml square by h square. Or rearrange this equation, that is equal to 8 ml square by h square into 1 by n. So the density of state d of v is inversely proportional to the 1 by n, or the quantum number n, inversely proportional to the quantum number n. Now, if we needed, we can just substitute 1 by n again from the equation of energy. That means En is equal to n square h square by 8 ml square. From n square is equal to, we can rearrange it to the another side. N square is equal to 8 ml square En by h square. Or that is n equal to, we can take the root 8 ml square En by h square all raised to 1 by 2, or 1 by n. 1 by n is equal to h square by 8 ml square capital U all raised to 1 by 2. Now we can substitute this equation here. Then the density of state equal to 8 ml square by h square into h square by 8 ml square E all raised to 1 by 2. Or again, if we calculate the rearrange this equation, this is 4, this is 8. So we can take this is 8, and we can take take the root of this, then rearrange the equation, then it will become m is cancelled, and also we can substitute as 4 L divided by h into, because you will h square, take the root h divided by h square, that's equal to h m by m, here root m divided by m, root m by root 2 into root, or m by 2e all raised to 1 by 2. This is the final expression for the density of states of Fermi level or Fermi energy using Sommerfeld theory. And we can explain, we can, it is depend upon e raised to 1 by 2 or minus 1 by 2. So if you draw the density of state with the energy of states E, if E is increasing this way and the density of state increasing this way, and we know that it is exponentially decreasing like this, and a particular level, the maximum field level is there, and that is called Fermi level. We can write it as this is EF. So less than this EF, the electron is completely free. So this is the Fermi levels up to this point. And up to here, EF, the electron is completely filled. So above that, at absolute zero, there is no electron is filled above this value, EF. So we discussed the Sommerfeld theory and Drude-Lorentz model, Weidmann-Franz law, based on the quantum model, and find out the expression for En and the psi value. And we discussed the Fermi energy, different levels, and based on that phenomenal energy and total energy, and now the density of state of this free electrons in the based on the Sommerfeld theory. Okay, thank you.